All right, let's take a look at the practice test. For the instructions, we're asked to find the inclination of the line theta. And before we jump in and look at some problems, I want to go over a few things that we talked about in the lesson. So if you really want to understand where this stuff is coming from, please revisit the lesson. Some of you just want to learn how to do these problems, so you can do that with this practice test. So the inclination of a non-horizontal line is the positive angle theta, less than 180 degrees, or pi if you're working with radians, measured counterclockwise from the x-axis to the line. And I'll give you a visual demonstration of what this is in a moment. Now, in our lesson, we derived a little formula that we can use to solve these problems. So we said if a non-vertical line has inclination theta and slope m, well then m, the slope of that line, is equal to the tangent of theta, where again, theta is the inclination of the line. All right, let's take a look at the first problem. So these problems are actually pretty quick if you understand the strategy. The first thing is you need to figure out what is the slope, because you're going to use this m is equal to the tangent of theta. Now, it's not always so straightforward. A lot of people will say, well, you can just use the inverse tangent function. If your slope m is positive, then it's very straightforward. So I would say if m is greater than 0, then you can just say that theta is equal to the inverse tangent of your slope m. So you can just directly do that. But what's going to happen is, let me slide this down. You're going to run into a problem if you have a negatively sloped line, because in that case, you're going to get an obtuse angle. And so when you use your inverse tangent function, you're going to get something in quadrant 4. Remember, tangent is negative in quadrants 2 and 4. So you're getting something in quadrant 4, and you're going to have to add 180 degrees to that to correct. So I'll say if your slope m is less than 0, theta would be equal to the inverse tangent of your slope m, but then you have to add 180 degrees, or pi if you're working with radians. It's up to you what you want to work with. So now that we understand these two things, let's just go ahead and jump into this. And I'm going to show you this visually in case you're a little bit confused in terms of what I just wrote. The first thing is you need to get the slope. There's lots of ways to do this. If it's in the form of ax plus by is equal to c, we've talked about the fact that the slope m is equal to negative a over b. So here a is going to be 1. So this is negative 1 over b is going to be 5. So this is negative 1/5 for the slope. So because of this, I can say that my theta is going to be equal to the inverse tangent of this negative 1/5 and then plus 180 degrees. Let's just do that real quick to see what we should get. So if I punch that into my calculator, let me get rid of all this and let me actually fix that, make it a little bit cleaner. So what I get is theta is going to be approximately negative 11 point, let's just go ahead and say 31 degrees. So that's coming from this part right here. And then I've got to add 180 degrees to that to correct, because again, this gave me the inverse tangent function, something in quadrant 4, again, rotating clockwise. I got to add 180 degrees to that to fix that and give me something in quadrant 2. I want my obtuse angle. So that's going to give me about 168 point, let's say 69 degrees. So this would be your answer. It's really quick if you understand the formulas. Now, let me do this the long way in case you're a little bit lost in terms of why things work out the way that they do. You could put this into slope-intercept form. So I could subtract x away from each side of the equation and cancel that away and say I have 5y is equal to negative x and then plus 20. This is going to go off the screen. You can copy it if you want. What I do here is divide everything by 5. And let's cancel this away. Y is equal to, again, you could put a negative 1 there to make that crystal clear. This is negative 1/5, so that's the slope. It's the coefficient of x. We found that earlier. And then plus 20 over 5 is 4. So let me grab this real quick. And I'm just going to come down here to a little sketch that I've made. So this line right here is y equals negative 1/5 x plus 4. You can see the y-intercept occurs at 0, 4. And then the slope is negative 1/5. Now, it's a little bit hard to look at this graph because it's not on the normal scale. Normally, everything is in terms of 1 unit as we move to the right to get a notch, or 1 unit as we go up to get a notch. But I put this in terms of 2 units as we go to the right or left, and then 2 units as we go up or down, just so it will fit, and we could see where this x-intercept is. I think that's pretty helpful. So basically, you're looking at this angle right here, and we said that that was about 168.69 degrees. So this right here would be theta. So what we end up doing is saying that m, the slope, is negative 1/5 and we use our formula, and we say that the tangent of theta is equal to m. So m is negative 1/5. So at this point, again, you would use your, let me get rid of all this. You would use your inverse tangent function, and you would say the inverse tangent of this negative 1/5 is equal to, or actually let me put approximately, and we said earlier, it's about negative 11.31 degrees. So again, if you look at that, on this guy right here, it's really hard to see. It's going to be that right there. So that angle, that's negative 11.31 degrees. Again, that's rotating clockwise. Okay, so that's what the inverse tangent function is going to give you if you have a negative argument. So to compensate for that, what you actually have to do is take this and add 180 degrees to get yourself back there. Okay, so you're going to start with that negative 11.31 degrees, add 180 degrees, and again, that's going to give me 168.69 degrees. So let's say this is 168.69 degrees. So you see what's going on. So let me erase all of this. We don't need this anymore. So that's why we can say that this is about 168.69 degrees. All right, let's take a look at problem 2. So we have 11x minus 5y equals negative 35. So again, I can do it really quickly and then also really slowly so that you get an idea of what's going on. The quick way is, again, ax plus by equals c. So if it's in this form, again, the slope m is negative a over b. So here a is 11. So negative 11 over b is a negative 5. So this is negative 5. So this is 11/5 for the slope. Now, if the slope is positive, again, this is very straightforward in terms of your answer. So you can just say theta is equal to the inverse tangent of this 11/5, your slope m. If you punch that into your calculator, you get about 65.56. So this is about 65.56 degrees. Now, that's the fast way. Let's do it the slow way in case you still want to know what's going on. So first, I would just solve this for y. So let's say that we would subtract 11x away from each side of the equation. Let's cancel this away. We'll say we have negative 5y is equal to negative 11x and then minus 35. Let's divide everything here by negative 5. So the answer is going to go off the screen, but we'll get it back in a moment. So let's get rid of this. And I'm just going to cancel this away and say y is equal to negative 11 over negative 5. Let's just put 11/5. Then times x. And then negative over negative is positive. 35 over 5 is 7. So that's what we're working with. So again, I made a little sketch. So y equals 11/5 x plus 7. So m here is going to be 11/5, and the y-intercept is going to occur at 0,7. So you can see that there. We're looking at this angle right here. And again, because this is a positively sloped line, this angle is going to be an acute angle. So it's real easy to find. You just say that the angle, theta, is found by the inverse tangent of the 11/5. So just plug in your slope there, and you're going to get that this is about 65.56 degrees. So we would say theta is equal to this, and then over here, you could say this is approximately 65.56 degrees. So again, if this guy is positively sloped in terms of your line, this is extremely straightforward because when you have a positive argument for your inverse tangent function, you're getting something in quadrant 1. So it's exactly what you want, so you don't have to make any corrections. All right, let's take a look at problem 3. So here we have x plus y is equal to 3. So again, the fast way, this is ax plus by is equal to c. So a here is 1, b here is 1, and c here is 3. So what I would say is that the slope m is equal to negative a, so negative 1 over b. So over b is 1. So negative 1 over 1 is negative 1. So that's your slope. It's just negative 1. So because this is negative, your theta is equal to the inverse tangent of this negative 1. That's your slope m. And then plus 180 degrees. You've got to correct for this because, again, this is going to give you something in quadrant 4, rotating clockwise. That's not what you want. So the inverse tangent of negative 1, I think everybody knows that that's negative 45 degrees. So this right here would be equal to negative 45 degrees plus 180 degrees, which would give me 135 degrees exactly. And again, I'll show you this using a longer method where we'll look at the graph. You can, of course, solve this for y really easily. This is y is equal to subtract x away from each side. So this is negative, let's write negative 1x and then plus 3. And let me paste this in. You can see the graph here. The y-intercept occurs at 0, 3, and the slope is -1. Down 1 to the right 1, down 1 to the right 1. You can see the slope is -1. Again, I'm looking for the angle of inclination. So that's going to be this guy right here. That's going to be my theta. And of course, because this guy is negatively sloped, well, what happens is when I have a negative argument for my inverse tangent function, I'm going to get this right here. So this is what I'm getting, but I need to correct and add 180 degrees to that. So if I say the inverse tangent of this -1, again, we all know that's -45 degrees. So that's what I'm getting there. But I don't want this, I want this. So I have to correct and add a straight angle basically. So I have to add 180 degrees to this. And so basically I would take this plus 180 degrees. And so we know this would give us -45 degrees plus 180 degrees. That's going to be 135 degrees. And this is actually exact. So let me get rid of this and say that theta is equal to this, or actually we can get rid of this, and we can get rid of this, and we can get rid of this. And I'll just put the answer here is that theta is equal to 135 degrees. All right, let's take a look at problem 4. So here we have 9x minus y equals -2. So again, ax plus by is equal to c. So a here is 9, b here is -1, and c here is -2. Not that you need c, but basically m, the slope, is equal to -a over b. So -9 over, for b you have a -1. So this is -9 over -1, which is +9. Okay, so that's my slope. Again, because this guy right here is positive, you can plug straight into the inverse tangent function. You will not have any issues. So you can say theta is equal to the inverse tangent of 9, and that is approximately, let's say, 83.66 degrees. So 83.66 degrees. So this is the answer we expect. Again, if you want to do this the long way, look at a graph. We could solve this for y. So let me subtract 9x away from each side of the equation. Let's cancel that. You have -y is equal to -9x minus 2. You can multiply everything by -1 or divide everything by -1. That's just going to change the sign of everything. So basically positive, positive, and then positive. Okay, let me grab this real quick. We'll come down here and look at this guy. So the y-intercept occurs at 0, 2, and the slope is going to be 9. So you can look at a point going down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then to the left 1. So that's a point on the line. All right, so thinking about this, we want this angle right here. So the angle of inclination, theta. Maybe that could be a little bit nicer. Let me see if I can make that better. So basically, we would say that the inverse tangent of this slope 9, let me get rid of this. So theta is equal to the inverse tangent of this slope m, which is 9. So again, this is approximately 83.66 degrees. So let me actually just write that in here. I can just get rid of this. So this is going to be about 83.66 degrees. So again, you focus on the fact that this is going to be an acute angle here because this is a positively sloped line. If this was a negatively sloped line, well, you'd have an obtuse angle. And again, that's where you have to do the extra work. All right, for the next few problems, we're going to change the instructions up. So now we want to find the acute angle theta between the two lines. All right, so we did talk about this in the lesson and we derived a formula. Let me just give you a quick recap. So the intersection of two distinct non-perpendicular lines forms two pairs of opposite angles. One pair is acute and the other is obtuse. The acute angle is known as the angle between the two lines. Let me highlight that. So the acute angle is known as the angle between the two lines. If they ask you for the obtuse angle, that'll be a different question. All right, so we did derive this formula in the lesson. It comes from the difference identity for tangent, so you can look that up if you want to see. But if two non-perpendicular lines have slopes m1 and m2, it doesn't matter how you label them because we have these absolute value bars here, the angle between the two lines is given as the tangent of theta is equal to the absolute value of m2 minus m1 over 1 plus m1 times m2. Now, because of the absolute value bars, you're going to get a positive result here. And so when you do your inverse tangent, you're going to get an acute angle because this is a positive argument you'd be feeding into it. So with these types of problems, it's very straightforward. You just plug into the formula. There's no correction needed. So all I'm going to do here is look at this first one. I'll give you a graph, and on the next ones, we can just blow through it. It's really not that complicated for these. So x minus 3y equals 6, and then 2x plus 3y equals negative 24. Again, how you want to get the slope is up to you. I'm just going to solve these for y for the first one because we are going to look at the graphs. So let me start with this one. So you have x minus 3y is equal to 6. Let me subtract x away from each side of the equation. That cancels. You get negative 3y is equal to negative x plus 6. Let me slide down here. Let me divide everything by negative 3. And this is going to cancel. So you're going to have y is equal to, let's write this as negative 1 over negative 3, which is just 1/3. So 1/3. Let me slide this over here. And then times x. And then 6 over negative 3 is negative 2, so minus 2. And now let's work on this one. So you have 2x plus 3y is equal to negative 24. Okay, so what you want to do here is subtract 2x away from each side of the equation. Let me cancel this. You're going to have 3y is equal to negative 2x minus 24. And I'm going to divide everything by 3. This would cancel. And you're going to end up with y is equal to negative 2/3 x. And then negative 24 over 3 would be negative 8, so minus 8. Okay, let me get rid of this. And let me stack these on top of each other. And I'm just going to go to the graph, although this isn't necessary. So you can see that they intersect right here. Okay, we're not trying to solve a system of equations or anything or find the point of intersection. I'm just showing you that they do intersect here. And so what's happening is you get these guys right here. These are vertical angles, right? So they have the same measure. And then you also have these guys right here. These are vertical angles, so they have the same measure. So basically what you want to think about is if you're asked for the angle between two lines, you're going to want this angle right here. Let's just call it theta in this particular case. It's going to be the acute angle. So this one would be acute, and then this one would be obtuse. Sometimes you're asked for the obtuse one, and all you have to do is figure out what is this right here, and then this is a straight angle, right? It's 180 degrees. So just take 180 degrees minus this theta, and you'll have your obtuse angle if you're asked for that, but usually you're not. You're most often asked for this right here, this theta. Okay, so how can we figure this out? Again, we just plug into the formula. So we're going to say that the tangent of theta is equal to the absolute value of, you have m sub 2 minus m sub 1. This is over 1 plus, you have m sub 1 times m sub 2. So let's just call this first slope m sub 1. So this is m sub 1. And let me get rid of this. And the second slope, let's call that m sub 2. So this is m sub 2. Get rid of this. You don't need that information anymore. Let me move this up here, and I'll just put a little comma. So I'm just going to plug into this guy, and this is getting a little busy. So for m sub 2, I'm going to plug in a negative 2/3. So negative 2/3. For m sub 1, I'm going to plug in a 1/3. So 1/3. And then down here, it's going to be 1/3, which is my m sub 1, times negative 2/3, which is my m sub 2. And again, you could have labeled these in any order. It doesn't matter because of the absolute value bars. So negative 2/3 minus 1/3, we have a common denominator. Negative 2 minus 1 is going to be negative 3. So this is negative 3 over 3, which we know is negative 1. So let me write this as negative 1. Down here, you have a negative times a positive, which is a negative. So let me write this as a minus here and get rid of this sign here. And so now we would basically think about this as 1 times 2 or 2 over 3 times 3, which is 9. So this right here would be minus 2 ninths. And I'm going to write this as 9 ninths. And so 9 minus 2 is going to be 7. So this is 7 ninths. 7 ninths. Now, what I'm going to do is drop the absolute value bars, and I'm going to make this positive. And from here, I'm just going to say that 1 divided by 7 ninths would just be found by flipping 7 ninths, right? So find the reciprocal of 7 ninths. That's just going to be 9 sevenths. So the tangent of theta is equal to 9 sevenths. So now we can say that theta is equal to the inverse tangent of 9 sevenths. And again, because this right here is going to be an acute angle, this argument is positive, we're good to go. We don't have to issue any corrections or anything like that. We can go ahead and just say that this is approximately, let's say 52.13 degrees. So 52.13 degrees. So that's going to be over here. Let me actually get rid of this. I'll just slide this over here like this. And I'll say this is approximately 52.13 degrees. Again, if you wanted this angle right here, so if you wanted this angle right here, all you have to do is think about the fact that this is 180 degrees. This is a straight angle. So take your 180 degrees minus 52.13 degrees, and that would give you about 127.13 0.87 degrees. Okay, so this is approximately. You're usually not asked for this, but if you are, that's how you'd find it. Most often you're going to be asked for this. So the answer here is that theta, the angle between the two lines, is about 52.13 degrees. So we have 5x minus y equals -1. We have x minus 2y equals 16. Again, if you're given your problems where your equations are in standard form, so ax plus by equals c, well then the slope, m, is going to be equal to -a over b. So let's call this m sub 1. This will be m sub 2. This is -a over b. And just go through and label things. So a here is 5. So I'm just going to plug that in. And b here is going to be -1. So plug that in. So this would be +5. Let me actually get rid of this and just say m sub 1 is 5. Over here, a is going to be +1. So -a would be -1. And then b is -2. So this is -2. So this turns out to be 1/2. Your formula is that the tangent of theta is equal to the absolute value of m sub 2 minus m sub 1 over 1 plus the product of these two. So m sub 1 times m sub 2. So just plug in. That's all you have to do. So this right here would be 1/2. And this right here would be 5. And then down here, you're going to have 5 times 1/2. And again, you can do that in any order. It doesn't really matter. You'll get the same answer. So for this one, you do need a common denominator. So you'd multiply this by 2 over 2. So by 2 over 2. And so that is going to give you 5 times 2 is 10 over 2. So this is minus 10 over 2. Now 1 minus 10 is going to be -9. So this is -9/2. So -9/2. Down here, 5 times 1/2 is 5/2. So 5/2. And then 1, you could write that as 2 over 2. And so basically 2 plus 5 is 7. So this is 7/2. So 7/2. Now, you have these absolute value bars. What you could do is just get rid of this negative here, get rid of those, and just say this is going to be 9/2. So that's your numerator from this complex fraction times, take the reciprocal of the denominator from the complex fraction. So that's 2/7. So this right here is going to cancel. And so you have 9/7. Now, in the last problem, we also saw that the tangent of theta was 9/7. So we already know the answer for that, but let's just go through it again. So this right here would be 9/7. And so theta is equal to the inverse tangent of 9/7. And again, that's going to be about 52.13 degrees. All right, let's take a look at problem 7. So here we have x plus 3y equals -24, and then 5x minus 6y equals 6. All right, let me slide down here. So again, you can say that because this is ax plus by equals c, that m, the slope, is -a over b. Same thing for this one, ax plus by equals c. So slope m is equal to -a over b. Let's call this m sub 1 and this m sub 2. Again, the order that you label things is not going to matter. So for this one, a is 1. So this is -1 over b is going to be 3. So -1/3 for the slope there. Then here, a is 5. So this is -5. And b is -6. So this is -6. Of course, a negative over a negative is a positive. So this is 5 over 6. Okay, let's plug into the formula. So the tangent of theta is equal to the absolute value of, you have m sub 2 minus m sub 1. This is over, you have 1 plus m sub 1 times m sub 2. So let's just plug in. So m sub 2 is 5 over 6. M sub 1 is -1/3. Be very careful here because you're going to have minus a -1/3. Of course, we can write that as plus a positive 1/3. And then down here for m sub 1, that's -1/3. And then m sub 2, that's 5/6. So what you could do to make this a little bit easier is just change this into a minus here because you had a negative times a positive, which would give you a negative. So just make that a minus. Okay, up here, I'm going to multiply this by 2 over 2 so I can have a common denominator. So this is 2 over 6. And so 5 plus 2 is 7. So this is 7 over 6 in the numerator up here. And then down here in the denominator, you have 1/3 times 5 over 6. That's going to be 5 over 18. So 5 over 18. Now, I'm going to change this and say it's 18 over 18. 18 minus 5 is 13. So this would be 13 over 18. So at this point, you can drop the absolute value bars because everything's positive. So this just turns into 7 over 6 times. I'm going to take the reciprocal of this, so 18 over 13. And so 18 divided by 6 is 3. So this becomes 7 times 3, which is 21 over 13. Okay, let me get rid of all this. So the tangent of theta is 21 over 13. So we could say that theta is equal to the inverse tangent of 21 over 13. And this is going to be about, let's say, 24 degrees. All right, let's look at one more of these. So for problem 8, we have x minus 4y equals 28. And then we have 15x plus 4y equals 36. So m is equal to negative a over b, because again, this is ax plus by equals c. Let's say that's m sub 1. This will be m sub 2, again, negative a over b, because this is ax plus by equals c. I can't stress this enough. Sometimes I give these formulas, and then if you get your equation in a different form, this doesn't work. So you have to make sure it's ax plus by equals c. Remember, you can always solve your equation for y and get your slope as the coefficient for x. That's something you can always do if this is a little confusing. So for this one, a is 1. So let's say this is negative 1 over, and then b is going to be negative 4. So we know that a negative over a negative is a positive, so this is positive 1/4. Here, for m sub 2, a is 15, so this is negative 15. And then b is 4, so this is over 4. Okay, let's just plug into the formula. So we're going to say that the tangent of theta is equal to the absolute value of, you have m sub 2 minus m sub 1 over, you have 1 plus m sub 1 times m sub 2. Okay, so plugging in, m sub 2 is negative 15 over 4. And then m sub 1 is 1/4. So this is 1/4. Down here, m sub 1 is going to be 1/4. And then m sub 2 is going to be negative 15/4. Okay, up here, you're basically going to have negative 15 minus 1, that's negative 16. So this would be negative 16 over 4, which is going to be negative 4. So this is negative 4. Down here, you would have a minus here. Let me get rid of this sign because positive times negative is negative, so just put that as a minus. So this would be 15 over 16. So 15 over 16. And you could change this 1 into 16 over 16. So 16 minus 15 is 1. So this is 1 over 16. Now, what you can do, because this is going to be in terms of the absolute value, you can drop the absolute value bars and just make that positive. And then what I'm going to do is say this is 4 over 1 times the reciprocal of 1 over 16, which is 16 over 1. So this is 64 over 1, or just 64. Okay, let me get rid of this and just say this is 64. And then all we have to do at this point is say that theta is equal to the inverse tangent of 64. Again, this is positive in terms of the argument. So you just key it into your calculator. You don't need to do any correction. And I get about 89 point, let's say 1, let's just go ahead and say 10 degrees. I know this 0 doesn't add any value, but let's just put it. So about 89.10 degrees. All right, for the next few problems, the instructions are going to change. So now we want to find the distance between the point and the line. So in the lesson, we talked about this nice little formula we can use when this situation comes up. You can also do this in a different way. For the next problem, because it doesn't work out too nicely, I'm just going to use this little formula. And then for the problem after that, what I'll do is actually go on the graph and show you another way to get this. So basically the idea is you want to put your equation that you're given for that line in what we call general form. Now, not every book calls this general form, but most people say that ax plus by plus c equals 0 is the general form of the line, whereas ax plus by equals c is the standard form. Again, this changes based on the textbook you're looking at, but usually it's called general form. Then the point that you're given is x sub 1 comma y sub 1. So you're just going to plug into this formula. Let me slide down here a little bit. So the distance is equal to the absolute value of ax sub 1 plus by sub 1 plus c, and this is over the square root of a squared plus b squared. So let me grab this real quick, and let me come down here and paste this in. Again, for the first one, I'm just going to use this little formula. The process of going through this on a graph is going to be a little bit tedious. I think too tedious for it to be useful. So I'm going to wait till problem 10, which is a little bit easier to work with. So for this one, again, I would label this as x sub 1 and y sub 1. So it's just the x coordinate from the point you're given, that's x sub 1, the y coordinate from the point you're given, that's y sub 1. That's all it is. And then this one, you have to rewrite this equation because right now it's in ax plus by equals c, so standard form. You need general form. So you have to have ax plus by plus c equals 0. So you have to have it in this format. Okay, so what I would do here is just say that this is x minus 4y. I could subtract 17 away from each side, so minus 17 equals 0. So now what you could do, if you want to label this, let's say that this 1 here, that's going to be your a. This, let's go plus negative. This negative 4, that's going to be your b. Let's go plus negative again. That negative 17, that's going to be your c. So you could just plug into what we have here. So for a, you have a 1. You can write it or not write it. I'm just going to write it for clarity. Then for b, you have a negative 4. So let's put a negative 4 there. And then for c, you have a negative 17. So let's put negative 17 in there. And you can just delete this now. You don't need it anymore. And actually, I forgot to put this down here. So a is 1. And b, again, is negative 4. Make sure you wrap this because negative 4 needs to be squared. If you just write negative 4 with no parentheses there squared, you key that into the calculator, you're going to get the wrong answer of negative 16. You want positive 16. It's very important. Then for x sub 1, you want negative 3. So let's plug that in there. And then for y sub 1, you want 4. Let's plug that in there. So we have 1 times negative 3, that's negative 3. And then negative 4 times 4, that's negative 16. Let's just write minus 16. And then you have plus negative 17. Let's just write minus 17 like that. And so negative 3 minus 16 is negative 19. And then you have negative 19 minus 17. That will give you negative 36. So this is negative 36. Of course, if you take the absolute value of negative 36, you're going to get 36. This would be over. 1 squared is 1. Negative 4 squared, again, this is wrapped. That's going to be positive 16. So this right here, 1 plus 16 is 17. So this would give me the square root of 17. Now, let me get rid of this and slide this over here. We don't want to leave a radical in the denominator. So let's multiply this by the square root of 17 over the square root of 17. And so this gives us 36 times the square root of 17 over 17 as our answer. All right, let's take a look at problem 10. So here we have x minus 2y equals negative 2. Again, you'd want to write that as x minus 2y. I'm going to add 2 to both sides, and this equals 0. So this is the general form. This is what you want. Let me go ahead and record this now. So my a is 1, my b is going to be negative 2, and my c is positive 2. And then over here, this point that you're given, negative 1 comma 3, well, this is your x sub 1, and this is your y sub 1. So just plug into the formula. Hopefully you didn't forget it. So the distance is equal to, up here, it's the absolute value of a x sub 1 plus b y sub 1 plus c. And let me make that a little bit longer. And this is over the square root of a squared plus b squared. So let's just plug in. For a, we have 1. Again, you can write it here or not. Let's just write it for clarity. You need to plug that in there as well. And then for b, you have a negative 2. So let's plug that in there. And then here, again, make sure you wrap this because it's negative. And then for c, you have a 2. So let's plug that in there. Okay, for the other guys, we're going to have for x sub 1, a negative 1. And then for y sub 1, it's a positive 3. So 1 times negative 1 is negative 1. And then negative 2 times 3 is negative 6. And then you have plus 2. So basically, you can convert this over into minus 6 here. So negative 1 minus 6, that's negative 7. And then negative 7 plus 2 is negative 5. So this right here would be the absolute value of negative 5, which is 5. Then down here, we have the square root of 1 squared plus negative 2 squared. So again, this negative 2 wrapped being squared, that's positive 4. And so this would be 1 squared, which is 1, plus 4, which is 5. So this is the square root of 5. So this is the square root of 5. And we're just going to rationalize the denominator. So times the square root of 5 over the square root of 5. So this gives me 5 times the square root of 5 over 5. And of course, you can cancel this 5 with this 5. So this gives me the square root of 5. All right, let's revisit problem number 10. We're going to do this using the longer method. And this method is going to prepare us for problem 11 when we derive the full formula. So I'm going to start out with my equation of the line, x minus 2y equals negative 2. I'm going to first put this in slope-intercept form, meaning I'm just going to solve it for y. So let's subtract x away from each side of the equation. This would cancel away. You'd have negative 2y is equal to negative x and then minus 2. Okay, from here, you want y by itself, so divide everything by negative 2. And let me get rid of this. And I'm just going to cancel this right here with this right here. Let me slide down just a little bit so I have some room. I'll say that this is y is equal to, so negative 1 over negative 2, that's 1/2, and then times x. You could say that this is plus negative here. So let's go plus negative 2 over negative 2, that's positive 1. So y equals 1/2 x plus 1. That is my slope-intercept form for the line. So first, I'm going to grab this, and I'm going to go to a little graph, and I'll explain things as we go. So let me paste in this equation here, and that's going to be for this guy in green. So y equals 1/2 x plus 1. If you look at this, the y-intercept occurs at 0, 1. So right there, that's the y-intercept. And the slope is 1/2. So from here, you could go up 1 to the right 1, 2. So there's a point on the line. Up 1 to the right 1, 2. So back on the line, so on and so forth. Let me get rid of these points here. And let me get rid of that as well. Now, you see that I have some other stuff going on here. Let me go back. And let me copy this point. So negative 1, 3. So typically when you see the formula, they're going to label this as x sub 1 and then y sub 1. So x sub 1 being the x coordinate from the point and y sub 1 being the y coordinate from the point. Okay, let me grab this and let me come back over here. I'm just going to paste that in. Let me change colors. So that's this point right here. So let me arrow to this and say that this point is negative 1, 3. And again, we refer to this x value as x sub 1, and then the y value as y sub 1. Maybe that x could be a little bit better there. Okay, let me delete this. We don't need this anymore. So now we see that we have this line right here, y equals 1/2 x plus 1, and you have this point right here. You also have this line right here, which at this point I haven't explained why it's there or what it does. When you want to find the distance between this point and this line, the shortest distance is the perpendicular line segment formed by the point and the line. So I'm just going to fill that in there and maybe use a different color here. So this is the line segment that we're talking about. So the idea basically is that let's label this point right here, which is going to be on both lines. It's on this line right here, the y equals 1/2 x plus 1. It's also on this line here in purple, which I'll get you an equation for in a moment. So that point of intersection, I'm going to call that x sub 2, y sub 2. And we can see from the graph that it's at 0, 1. Although I'm going to show you where this comes from in a moment by solving a system of equations. Let's call this x sub 2, y sub 2. So really all you'd have to do to solve this is to figure out the distance between these 2 points, and you can use the distance formula for that, or you can use the Pythagorean theorem. Now let me show you where this came from. Essentially, what you would do is you would say, okay, I have the equation of this line that was given. I need the equation of this line right here. Okay, in order to get the equation of this line right here, I know that they're perpendicular. So in other words, this right here is a right angle or a 90-degree angle. And so because of that, the product of the slopes would be negative 1. So for this one right here, let's just say that I would have y minus y sub 1 is equal to m the slope. So I would take the reciprocal of this, which would be 2 over 1, and make it negative. So that's negative 2. Let me actually put the full formula here. So m times the quantity x minus x sub 1. And I'm going to plug in a negative 2 for m the slope. So I can plug in a negative 1 for x sub 1. So minus the negative 1 is plus 1. And then for y sub 1, I can plug in a 3. Now all I have to do is solve this for y, and I'll have the slope-intercept form of this line. So this would be y minus 3 is equal to, I'm going to distribute this. So this would be negative 2x and then minus 2. And so add 3 to both sides of the equation. Let me get rid of this. And so basically you'd have y is equal to negative 2x, and then negative 2 plus 3 is going to be positive 1. So let's go ahead and say plus 1. Okay, let's get rid of this. Let me tighten this down a little bit. So this is y is equal to negative 2x plus 1. And you can look at the line and see that. So the y-intercept occurs at 0, 1. So that's right there. And the slope is negative 2. So you fall 1, 2, go to the right 1. There's a point. Fall 1, 2, go to the right 1. There's a point. If it wasn't obvious where that point of intersection was, so maybe you had an example like we did with problem number 9, where you had these non-integer values at the point of intersection, well, then you can just solve a system of equations and you could figure out, well, what is the x sub 2, y sub 2, so I can plug into the distance formula. So what I would do here, let me do this off on the side. I have y is equal to negative 2x plus 1. and I have y is equal to 1/2 x plus 1. Now, we already know we're going to get 0, 1 as the solution for this system. What I would do here is take this and to plug it in for y. Okay, so basically I would say that I have 1/2 x plus 1 is equal to negative 2x plus 1. And so what you could do is multiply everything by 2 to clear this denominator. So you would have x plus 2 is equal to negative 4x plus 2. So I just multiplied everything here by 2 to clear that denominator. Let's get rid of that. And so at this point, I'm going to add 4x to both sides of the equation. And I'm going to subtract 2 from both sides of the equation. So this is going to cancel and this is going to cancel. Now, because this side is completely canceled, I'm going to put a 0. Okay, negative 4x plus 4x is 0. 2 minus 2 is 0. So put a 0 there. And then over here, x plus 4x is going to be 5x, and this cancels. 2 minus 2 is 0. So 5x is equal to 0. Let me get rid of this and drag this up here. And of course, if we divide both sides of the equation by 5, this cancels. You get x is equal to 0. But we already knew that. Let me get rid of that. And we'll say that x is equal to 0. Now, what you can do is plug in a 0 for x in either original equation. Does not matter. This one's pretty quick. You'll say y is equal to 1/2 times 0, just plugging that in for x, plus 1. And of course, 1/2 times 0 is 0. And so you get y is equal to 1. So we get 0, 1 as the point of intersection. So coming back, we already knew that, 0, 1, that's the point of intersection. It solves the system of equations because it lies on both lines. So now that we have this point, and we know our coordinates, you could just plug into the distance formula. So you have negative 1, 3. Again, this is x sub 1, y sub 1. And then we have 0, 1. This is x sub 2, y sub 2. Okay, let me grab this and let me paste this in. Okay, for the distance formula, I think we all know this is the square root of, you have x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Okay, so for x sub 2, you have 0. And then for x sub 1, you have a negative 1. So minus the negative 1 is plus 1. And obviously 0 plus 1 is just going to be 1. So this is 1 squared, which is 1. Over here, y sub 2 is 1. And y sub 1 is going to be 3. So 1 minus 3 is negative 2. So this is negative 2 squared, which is positive 4. So you have 1 plus 4 here. Again, this is the square root of 5, right? So basically you get the distance is equal to the square root of 5. And you can say that the distance right here is going to be the square root of 5. So from this point right here, negative 1, 3, to this point right here, 0, 1, it's the square root of 5. That's the distance. And again, that's going to be your distance from the point that you were given to the line that you were given. So a lot more work to get the same thing from the very easy formula. In the next example, you're going to see where we're going to derive the formula from scratch. And hopefully after looking at this example, you'll have an idea of what to do. All right, for problem 11, now we want to think about deriving the full formula. So I'm just going to tell you in advance, this does take quite a while because we're just going to do it using algebra. Some people prefer to do this using a geometric approach. That's a little bit quicker. So the first thing is, I see that I have my equation ax plus by plus c equals 0 given in what we call general form. So that's what most books would call that. Then my point is just labeled as x sub 1, y sub 1. So the strategy will be the same as what we looked at in problem 10 when we did that using the longer approach. So first, let me write out what we would expect. So the distance between this line and this point is equal to the absolute value of ax sub 1 plus by sub 1 plus c, and this is over the square root of a squared plus b squared. So a very easy formula to work with, but the idea here is we're going to show where it comes from. Okay, so to think about the steps that would be involved, let's look at a simple sketch. So first off, this line in yellow, that's the line that you're given. So this is the ax plus by plus c equals 0. And then the point that you're given, that's going to be right here where we call this x sub 1, y sub 1. Now you'll notice that we have this line segment here, and we have this other point here. So where does that come from? Well, basically the shortest distance from this point that you're given, again, the x sub 1, y sub 1, to the line that you're given, again, the ax plus by plus c equals 0, is the perpendicular line segment that joins that point in that line. So that's going to introduce this point right here, which we're going to call x sub 2, y sub 2. Now notice that I said that this guy was a perpendicular line segment. So that means this guy right here is a right angle or 90-degree angle. So what I'm actually going to do is extend this a little bit to make it easier to understand. So I'm going to say that these two lines are perpendicular, and the point of intersection, this point right here, is going to be that x sub 2 comma y sub 2. So let's think about how we can get this guy. We would already know this guy. So what we're going to need to do is basically set up a system of equations and find this x sub 2 comma y sub 2. That's going to be the goal. And then we can plug into the distance formula to find the distance between this point right here, this x sub 1 comma y sub 1, and this point right here, this point of intersection, this x sub 2 comma y sub 2. Again, this right here to this right here, that's the distance between this point that's given and the line. That's all we're finding here. So to get started, I'm going to write my equation ax plus by plus c equals 0 in slope-intercept form. So that just means I'm going to solve it for y. So to do that, I'm going to subtract ax away from each side of the equation. I'm also going to subtract c away from each side of the equation. So this is going to cancel, this is going to cancel. And so you're going to have by is equal to negative ax and then minus c. So what I'm going to do at this point is divide everything by b. And let me slide down here a little bit. So this would cancel. And basically you would have y is equal to, let's write this as negative a over b, then times x, and then minus c over b. I'm going to grab this real quick, come to a fresh sheet. I'm going to paste this in, and I'm just going to call this equation 1, just for reference sake, because we're going to end up solving a system of equations. The next thing is you need to figure out the equation for this line right here. So we need to figure out what is the equation of this line. So with perpendicular lines, the product of the slopes, that's going to be negative 1. So let's go back, and this slope right here is negative a over b. So if I said negative a over b times some unknown slope m is equal to negative 1, well, basically you could multiply both sides by negative b over a, so times negative b over a. And so this right here is going to cancel and give you 1. So m, let me write a 1 there, is equal to negative times negative is positive, so this is just b over a. So that's going to be the slope for my perpendicular line. Okay, let me get rid of this, and let's call this equation 2. So we're going to say this is y minus y sub 1 is equal to m the slope times the quantity x minus x sub 1. So this x sub 1 and this y sub 1, again, that's the point that you're given. If you go back, that's this point right here that's going to be on this line. So that's what we're using. And then we know the slope, so that's why we're using something called point slope form. I'm going to plug in for m since I know what that is. So that is b over a. And then I'm just going to solve this for y. So you could add y sub 1 to both sides of the equation. So this right here is going to cancel away. And what you're going to have is y is equal to b over a times x and then minus b over a times x sub 1. So I'm just distributing this into each guy. And then plus y sub 1. Let me get rid of this. And maybe I can bring this down a little bit. So let me change my color. So this is equation 2. All right, so to solve this system, I'm going to use the substitution method. So I'm going to take this right side of equation 2, so this guy right here, and I'm going to plug that in for y in equation 1. Y is equal to this, so that means I can plug this in for y here. So basically that's going to give me b over a times x minus b over a times x sub 1 plus y sub 1. And this equals negative a over b times x minus c over b. So let me grab this real quick, and let me come down here and paste this in. Now we have to think really carefully about what we're trying to do. You see that you have an x here and an x here, but then you also have an x sub 1 here. So this confuses a lot of people. If you go back to your little sketch, what's happening is you're trying to solve for x in this particular case. What you're trying to obtain is the x value for this point right here of intersection. That point that basically solves the system. It's where the two lines will intersect, and so it's the solution for the system. So right there, we've named this as x sub 2, but over there, when we solve for this, it's just x. So I'm going to solve for that. Eventually, I will rename it to x sub 2. For right now, we're just going to call it x. Just note that it's different than this x sub 1. That is from that point that we were given. So if we go back, that's this guy right here. So those are different. Okay, so it's very important. This is where people get tripped up. All right, so with that being said, let's get started with the solution here. What I want to do is get this over to the left and then get all this stuff over to the right. So I would add a over b times x to both sides of the equation, and this will cancel away. Let me actually do this in different lines. So let me write this as a over b times x, and then plus b over a times x, and then minus b over a times x sub 1 plus y sub 1, and this equals negative c over b. Now, this x and this x, again, that's what I'm trying to solve for, so leave those on the left. This x sub 1, again, that's different. You're going to get that to the other side. So I'm going to add b over a times x sub 1 to both sides of this equation. Let me put this up here where it goes. And then I'm going to subtract y sub 1, let me just do that over here, away from each side of the equation. So this guy right here is going to cancel away, and so is this guy. So that gives me a over b times x plus b over a times x is equal to, over here, I have negative c over b, and then plus b over a times x sub 1, and then minus y sub 1. I am trying to solve for x here. So what can I do? You might be thinking, how in the world are we going to solve for x? Remember earlier in the course, we talked about solving literal equations, and we had a strategy for this. Basically, you would factor the x out. So you're going to pull that out in front of some parentheses, and maybe that could be a little bit better, like that. And so inside the parentheses, you would have a over b, so a over b, and then plus b over a. And you could write this in a different way. You could put the x over here. It really doesn't matter. X is multiplied by this. So basically, this is the coefficient of x. So we'll say this equals negative c over b, and then plus b over a, and then times x sub 1, and then minus y sub 1. I'm actually going to grab this and go to a new sheet so we don't run out of room. And what I'm going to do is divide both sides of the equation by this a over b plus b over a. Again, that's the coefficient of x. It's just like if I had 3x is equal to 6, and I divide both sides of the equation by 3, well, that's all I'm doing here. I'm just dividing both sides of the equation by the coefficient of x. Well, a over b plus b over a, that's the coefficient of x. So let me get rid of this, and let me divide this over here. So this is a over b plus b over a. So we're going to have this as x is equal to negative c over b, and then plus b over a times x sub 1 minus y sub 1. And this would be over your a over b, and then plus b over a. Maybe that a could be a little bit better there. All right, so at this point, what you want to do is simplify as much as you can. Now, you could come down here and get a common denominator and take that approach, but I think the quickest way to do this is to use our knowledge of simplifying complex fractions. So we'll think about this part up here as the numerator of the complex fraction, and this down here as the denominator of the complex fraction. And so think about all the denominators involved in this problem. You have a b, you have an a, you have a b, and an a. So the least common denominator is a times b. So all you have to do, let me unhighlight everything here. You're just going to multiply the numerator and denominator. Let me actually just slide this over here so this fits. So x equals, multiply the numerator and denominator of the complex fraction by that LCD, which is AB. So I'm going to go AB over AB. So I'm just multiplying by 1. I'm not changing anything. So let's go x is equal to, you're going to have AB times this up here. So negative c over b plus b over a times x sub 1 minus y sub 1. Down here, you're going to have this AB times this quantity a over b plus b over a. And just distribute this in. So this is going to get distributed here, and this is going to get distributed here. So we'll say that this is going to be x is equal to, you'll have ab times negative c over b, and then plus ab times b over a times x sub 1, and then minus ab times y sub 1. This would be over. Down here, you're going to have ab times a over b. Maybe this a could be a little bit better there. And then we're going to have plus ab times your b over a. And let me make that a little bit better there. Now thinking about this, we can see a lot of stuff's going to cancel. So this b with this b, this a with this a, and then nothing over here. Down here you have this b with this b, and then this a with this a. So let's go ahead and write this as x is equal to, a times negative c would be negative ac. You could also write negative ca, whatever you want to do. And then I'm going to put plus b times b is b squared, so b squared times x sub 1, and then minus, you'll have a b y sub 1. This would be over, you have a times a, that's a squared, and then plus b times b, that's going to be b squared. So that would be my x. Again, eventually this is going to be called x sub 2. So let me grab this real quick. and come back up here and just paste this here. So I know my x value that solves this system of equations. So that's the first thing. Now I need to figure out the y value that's going to solve the system of equations. So I can have the x comma y, and then again, I'll rename that as x sub 2 comma y sub 2, and then I can plug into the distance formula. Now to find the y value that I'm looking for, what I'm going to do is plug the x value that I have in for x in either equation 1 or 2. Obviously, equation 1 is easier to work with. So we're going to take this right here, which is what x is equal to, and plug it in right there. I'm not going to be able to fit this all on the screen, so I'm going to have to slide down a little bit and say y is equal to negative a over b. So that's coming from right there. And then for x, I'm plugging this in. I'm going to do that in a moment. And then out here, let me just wrap this with parentheses temporarily. We're going to have minus c over b. Okay, so hopefully you're clear on what we're doing. So let me get rid of this highlighting here and also here. I'm just going to slide down. And what I'm going to do is actually move this down. So this is minus c over b. And I'm just going to copy this. So this is times this guy right here. So I'm going to try to do this as cleanly as possible. Let me move this down here. And move the y down there. So we would have negative ac plus b squared x sub 1 minus a b y sub 1. And let me move this out here. So minus c over b. And then this is over your a squared plus b squared. And all we're going to do here is just simplify. We already have y equals something. So we just want to make this as simple as we can. So this right here, I'm going to multiply negative a by each term here. So let me actually show this. So y is equal to, basically I'm going to say this is negative a times negative ac plus b squared x sub 1 minus a b y sub 1. So this guy is going to get distributed to each guy inside the parentheses. And then down here, you would have b times the quantity a squared plus b squared. I'm not going to distribute this because you're going to have to factor it back out if you do. So just leave the denominator alone here. So then minus, you have c over b, and I'll say this is y is equal to negative a times negative ac, that's positive a squared c. And then negative times positive is negative. A times b squared x sub 1 would be a b squared x sub 1. And then negative times negative is positive. A times a is a squared. And then basically you just have b y sub 1. So then you have minus c over b. Let me put my denominator down here. This is b times the quantity a squared plus b squared. Let me slide this over here and see if I can fit this. So this will be multiplied by your a squared plus b squared. So barely fit that on the screen. So a squared plus b squared. So let me come down here and basically say that y is equal to a squared c minus a b squared x sub 1 plus a squared b y sub 1. And then basically, this is where it gets a little tricky. What I would do here, this whole thing is being subtracted away. So you have to be very, very careful. I would write this as minus, and I would put some brackets here, and then say c times the quantity a squared plus b squared like this. It's very easy to make a sign mistake here because again, you have to remember that this whole thing right here is being subtracted away. So let me put this over. You have a common denominator. It's b times the quantity a squared plus b squared. So b times the quantity a squared plus b squared. I'm basically going to first write this, and I think I can just erase this and say this would be a squared c plus b squared c. In other words, this is going to get distributed here. Let me just write another line. I don't want to lose anybody. So y is equal to a squared c minus a b squared x sub 1 plus a squared b y sub 1. And then let me put my brackets here. So this would be distributed. So it would be a squared c, and then basically plus b squared c. The reason you have those brackets there is so that minus gets distributed. In other words, you can think about this as plus a negative 1 and distribute that negative 1 to each guy. And I think we're safe to do this now. Basically, that's going to change the sign of each of these guys. So this becomes a minus and this becomes a minus. So it's very important to have those brackets or maybe another set of parentheses or whatever you want there to make sure that you end up with negative a squared c and then a negative b squared c. So then let me put this over b times the quantity a squared plus b squared. What you're going to notice here is that you have this a squared c, and this negative a squared c, that's going to cancel and become 0. So I'm just going to line this out with this. Now, if I look at what's left, let's go ahead and say that y is equal to negative ab squared x sub 1 plus a squared b y sub 1 minus b squared c, and this is all over b times the quantity a squared plus b squared. So there's one other thing we're going to do, and basically we're going to factor out a b from the numerator. So notice here you have b squared, and you have b and then b squared here, and you have a b down here. So we'll have y is equal to, I'll put my b out in front of some parentheses, you'll have negative a b x sub 1, and then plus you're going to have a squared y sub 1, and then minus you're going to have b c. Okay, let's put this over. You have your b times the quantity a squared plus b squared. So this would cancel with this. And so what that is going to give us is a final y is equal to, you have a negative a b x sub 1 plus a squared y sub 1 minus bc. And this is all over your a squared plus b squared. So let me grab this and I'll paste this in. So this is going to be our y. What is this x and what is this y? We just solved a system of linear equations. And if we go back, this right here is the point of intersection. We just found the x value and the y value. All I'm going to do for the purposes of deriving this formula, I'm going to call this x sub 2 comma y sub 2 because I'm going to plug into the distance formula. So I'm going to have this point right here and this point right here. So that's what I'm trying to do. So if we go back, I'm going to now label this as x sub 2 and y sub 2. So I'm just changing the labeling. I know a lot of people get confused by that, but basically it's just so we can plug into the distance formula. All right, so now what we're going to do is plug into the distance formula. This is going to be extremely hard to fit on the screen. Let me come down here to a new page. So we know the distance between 2 points on the coordinate plane is the square root of, you would say, x sub 2 minus x sub 1 quantity squared, plus we have y sub 2 minus y sub 1 quantity squared. You are going to plug in for x sub 2 and y sub 2. So we have that up here. Just coming back, here's x sub 2, here's y sub 2. I'm going to take one of these at a time. So I'm just going to grab this one, copy it, and come down here, and I'm going to paste this right here. And I'm only going to work on this part right here. So basically, I'm going to say this is x sub 2, and then minus x sub 1, and this is quantity squared. So I'm just going to do this, simplify it. We'll come back and update this, and then I'll do this one separately. Let me go ahead and grab this real quick, come down here and paste this in. All right, so the idea here, let me actually scoot this down a little bit because you're gonna need some room. You wanna get a common denominator. So I'm gonna multiply this by a squared plus b squared. Or actually, let me wrap this like this. I think it's a little bit better to do it like that. So this would be over a squared plus b squared. Okay, so when you do that, basically you're gonna have negative ac plus b squared x sub 1 minus a b y sub 1. And then just like I did previously, I'm going to put minus and put some brackets here, and I'll just show this as x sub 1 times the quantity a squared plus b squared like this. Close that down because this whole thing is being subtracted away. So you have to be very, very careful there. So let me close this down and then put that this is squared. Let me make that a little bit better here. And this right here is all over the common denominator of a squared plus b squared. What we're going to do is say this is equal to, so let me distribute this in like that. You'll have a negative ac plus b squared x sub 1 minus a b y sub 1, and then minus, let me put these brackets here. This would be a squared x sub 1, and then plus b squared x sub 1. Okay, let me close that down. Now, at this point, this negative, again, would be distributed. You can always put this as a plus negative 1 and show it like this if it's easier for you. But at the end of the day, both of these will just be a minus. So there'll be a minus here and a minus here. Let me close that down, and we're going to square this. And let's put this over a squared plus b squared. At this point, you'll see that you have b squared x sub 1 and negative b squared x sub 1. So you can cancel those. So let me go ahead and cancel this one with this one. And so now what you're looking at, let me slide down here a little bit, is going to be negative ac minus a b y sub 1 minus a squared x sub 1. Let me wrap this real quick. And we're going to square this, and this is over a squared plus b squared. I want you to notice that there's an a here an A here, and an A here. And there's also a negative or a minus, and a minus. So that means I can pull out a negative A. And I'm going to write this as negative A being pulled out, and then times what's left would be C plus B times y sub 1 plus, you'd still have an A times x sub 1. So I just pulled out a negative A from each guy. So that leaves you with a positive C, and then a plus by sub 1, and then a plus ax sub 1. Now, you could reorder this, and I recommend it so it makes it easier to understand what's going on. You could really say that this is ax sub 1 plus by sub 1 plus c. Remember, you can add in any order. So I'm just going to change that now. So this is ax sub 1 plus by sub 1 plus c. And let me put this over your a squared plus b squared, and then this is squared. So what I'm going to do here is use my rules of exponents. So basically, let's say I had something like x, y over z, and this whole thing was squared. I could say this is x squared times y squared over z squared. So that's the same thing here. Remember, this is multiplication. So basically, what I can do is say legally that this is equal to negative a being squared, and then times this ax sub 1 plus by sub 1 plus c being squared over this a squared plus b squared being squared. Okay? Now, this right here, realize that if it's the negative of a, this is wrapped and this is squared. This is the same thing as a squared, right? So basically you could say, let me do this off to the side so nobody's lost. You could say negative a squared is equal to negative 1 squared times a squared, which just equals a squared. Okay, you could show it like that. A lot of people will just eyeball that and say, okay, well, I know the negative is going to go away because it's being squared. And let me change this over to a squared like we just discussed. And I'm going to actually have to fit that in there somehow. All right, so I went ahead and just used MathJax to make a little image. So it's a lot cleaner and easier to see what I have here versus me trying to squeeze that in with my handwriting. So we have simplified this part right here. Remember, this was x sub 2 minus x sub 1 quantity squared. We want to do the same thing for this guy over here. So y sub 2 minus y sub 1 quantity squared. I'm going to go up and grab my y sub 2. So let's get that real quick. And let's come down here and just paste this in. So this is y sub 2, and I want to subtract away this y sub 1. And of course, I'm going to wrap this, and I'm going to go quantity squared. So let's go ahead and grab this real quick, and we'll come down here, and let's see if we can simplify this. So the first thing is I want to get a common denominator. Let me just slide this down. I'll put it in a second. So I'm going to multiply this by a squared plus b squared, and this would be over a squared plus b squared. Let me close this back down and say this is squared. Okay, let's put equals here, and then I'll put this in. So you're going to have negative abx sub 1 plus a squared y sub 1 minus bc. Now here's where, again, you need to be really careful. This whole thing is being subtracted away. So what I would do is say that you have minus, and you can use brackets or parentheses, whatever you want to do. Then put this in here, so y sub 1 times the quantity a squared plus b squared. Close that down, and then we're going to close down the brackets. So I can just write this over the common denominator, a squared plus b squared. Okay, let me slide down a little bit. Let's close this down here and say this is squared. All right, at this point, you would want to distribute this into each guy inside of the parentheses. So let's say this equals negative abx sub 1 plus a squared y sub 1 minus bc. And then for this guy, you have this minus in front of these brackets. This right here is going to be a squared y sub 1 and then plus b squared y sub 1. The purpose of the brackets, again, is to remind you that you've got to distribute that minus, or say this negative 1 is going to be distributed to each guy. So at the end of the day, both of those are going to have a minus sign in front. So this would be a minus and this would be a minus. I didn't mean to get rid of that, so let me draw that back in. So then this would be over this common denominator of a squared plus b squared. Okay, let me put in some parentheses here, and this, of course, is squared. At this point, it's not that bad. You notice that you have a squared y sub 1, and then you have a negative a squared y sub 1. So those are going to cancel. So let me show this as canceling with this. And then let me write this down here. We'll say this equals negative abx sub 1 minus bc, and then minus b squared y sub 1. This is all over a squared plus b squared. Let me wrap this, and this is going to be squared. What you would notice here is that you could pull out a negative b from the numerator. Here's a negative, here's a negative, here's a negative, here's a b, here's a b, here's a b squared, but let me just highlight the b. So basically, you are going to pull that out. Let me circle that, and circle that, and circle that. Okay, so you're going to pull that out. And actually, if you want to make that crystal clear, you could write that as b times b like this, and then circle that. All right, so we'll say this is equal to, in the numerator, pull out the negative b. So I'm going to pull out a negative b. And then inside the parentheses, I'm going to put, you'd have a positive ax sub 1. So ax sub 1. Pull out the negative b. I'd have a plus c. Pull out the negative b. You'd have a plus by sub 1. Now, I would reorder this and put by sub 1 first, like this, and then plus c, close that down, and then this would be over this a squared plus b squared. So again, all I did was pull out a negative b from the numerator. Now, let's close this down and square it. At this point, I'm going to use my rules of exponents. Again, x, y over z. If that was squared, this is x squared times y squared over z squared. That's exactly what I'm going to do here. Remember, this is multiplication. Let's say this equals negative b squared, and then times this quantity ax sub 1 plus by sub 1 plus c, and this is quantity squared, over, you're going to have this quantity, so a squared plus b squared being squared. Now again, with this guy, this negative b being squared, you can legally write that as b squared. So I'm just going to delete that and put that as b squared. Now let's come back up and let me paste this in here. So this is going to get plugged in right there. So once again, I just used MathJax to make a nice clean image. It's a lot better than me trying to squeeze this in with my handwriting. And basically at this point, it's very easy to see what you're going to do. You have a common denominator. So I'm just going to say the distance is equal to the square root of, I'm going to have a squared times the quantity ax sub 1 plus by sub 1 plus c, and this is squared, plus your b squared times the quantity ax sub 1 plus by sub 1 plus c, and this is quantity squared. Let me move this down here. This is over, again, I have a common denominator, so it's a squared plus b squared quantity squared. At this point, I want you to notice that you have this right here that is exactly the same as this right here. Okay, so those are the same, so you can factor that out. So basically what you would have is the distance is equal to the square root of, this gets pulled out because it's common. So let me put this out here. So ax sub 1 plus by sub 1 plus c, and this is quantity squared. And then this is going to be times what's left. Well, if I pulled this out, I would have a squared left. So let me put a squared. And then plus, if I pulled this out, I would have b squared left. And then this is over. You have this a squared plus b squared. I didn't put that in there, so squared. And then quantity squared. At this point, you'll notice that this would cancel with one of these. So that gives me d, or the distance, is equal to the square root of, now you have this ax sub 1 plus by sub 1 plus c, quantity squared, over, now you have one of these. So you can just write a squared plus b squared. Maybe this could be a little bit better. So let me do that like that. At this point, you're going to use your rule where basically if you have the square root of, let's say, x over y, this is the square root of x over the square root of y. Okay, so that's all we're going to do. So I'll just say d is equal to the square root of this quantity ax sub 1 plus by sub 1 plus c being squared, over, we're going to have the square root of a squared plus b squared. For this one right here, remember in the formula, we have the absolute value bars. So where does that come from? Remember, earlier in the course, we said if we had something like the square root of negative 2 being squared, well, negative 2 is squared first, so that gives me positive 4, and then the square root of 4, so the square root of 4 would be 2. So basically, this is equal to the absolute value of what's inside here. So the absolute value of -2, which is 2. Another way you can put this is, you could say that the square root of x squared is equal to the absolute value of x, and that's what we're going to use here. So we have the square root of something squared. So what we're going to do is replace this and say that the distance is equal to the absolute value of ax sub 1 plus by sub 1 plus c. So just applying that rule, a little bit more complicated, but that's what we're doing. Then this is over. You have the square root of a squared plus b squared, and so now we have our formula. A lot easier just to work through a typical example than to derive this formula, but sometimes the teacher will make you do this just to get a lot of algebra practice, and if you have to, then you can look at this video. And I would recommend, if you went through the whole process with me step by step, wait a few days and let it not be as fresh, and then try to do it on your own again, and then you can come back to the video if you need some help.